Hello, and welcome to this video about stem and leaf plots. Today we'll learn how to read a stem and leaf plot and discuss what sorts of information it's used to display. Before we get started, let's review a few things. First, a dataset is a collection of numbers that relate to a specific topic. For instance, class scores on a math test are a dataset. Mathematicians use graphs to illustrate datasets. A stem and leaf plot is a type of graph that displays quantitative data. Each data point in a stem and leaf plot gets broken down into two components, the stem and the leaf. The stem is the first digit or digits of the data value, and the leaf is its last digit. A stem and leaf plot looks like a table with two columns. The left column contains the dataset's stems, and the right column contains its leaves. Let's look at an example of a stem and leaf plot together. In the table shown, the stem column shows the tens place for numbers that appear in the dataset. The leaf column shows the ones place for each data value. The data values with 1 and the tens place are 12 and 14. The data values with 2 in the tens place are 25 and 28. The data values with 3 in the tens place are 31, 35, and 37. The data values with 4 in the tens place are 43, 44, and 49. Stem and leaf plots are a useful way to organize quantitative data. We can interpret a stem and leaf plot to answer questions about the dataset. Let's say that in this stem and leaf plot, each number is the age of a family member. Given this context, we can answer questions about the dataset using the stem and leaf plot. For instance, if I ask how many family members are in their 40s, you can see that 3 data values have 4 as their stem. Therefore, 3 family members are in their 40s. Understanding how to read and interpret stem and leaf plots helps us interpret data. Let's look at another stem and leaf plot together. This stem and leaf plot shows student test scores on a math assessment. Now that we know how to read stem and leaf plots, let's see if we can answer a few questions about the dataset. What was the lowest score earned on the assessment? The lowest score earned on the assessment is 62%. Recall that stem columns show the first digit or digits of the data value. The lowest stem shown is 6, so the lowest test score is in the 60s. Each leaf shows the ones place value of each number in the dataset. The lowest leaf with a stem of 6 is 2, so the lowest score in the dataset is 62%. How many students earned a score of 80% or higher? To answer this question, we need to count how many numbers have a stem of 8, 9, or 10. Since there are 5 leaves shown for a stem of 8, there are 5 test scores in the 80s. 80, 80, 83, 84, and 85. Since there are 3 leaves shown for a stem of 9, there are 3 test scores in the 90s. 90, 95, and 97. There's 1 leaf shown for a stem of 10, so the test score is 100%. Adding these together, 9 students earned a score of 80% or higher on the math test. How many students took the math assessment altogether? To figure out how many students took the math assessment, we need to count how many pieces of data we have in this data set. Looking at the leaves listed for each stem, we can count how many test scores occur in each frequency. 3 plus 8 plus 5 plus 3 plus 1 equals 20, so there are 20 test scores altogether. Therefore, 20 students took the math assessment. Now it's your turn. The stem and leaf plot shows the average temperatures in Philadelphia from the last 14 days. All temperatures are recorded in degrees Fahrenheit. Use the stem and leaf plot to answer the following questions. What is the maximum temperature recorded? What is the most repeated temperature in Philadelphia over the last 14 days? How many days recorded a temperature greater than 30 degrees but less than 40 degrees? Pause the video and analyze the stem and leaf plot and see if you can answer these questions yourself. When you're ready, resume the video and we'll go over the answers together. Now that you've tried these problems yourself, let's go over them together. What is the maximum temperature recorded? To find the maximum temperature, look at the largest stem value, which is 6. Temperatures recorded in the 60s are 60, 61, 61, and 62. Therefore, the maximum temperature recorded is 62 degrees Fahrenheit. What is the most repeated temperature in Philadelphia over the last 14 days? The number that occurs most often in a dataset is also called the mode. To find the mode, look for the repeated leaf numbers for each stem. Looking at the leaves for a stem of 5, we see the number 2 recorded 3 times. Since no other leaf number repeats itself 3 or more times, this number is the mode. With a stem of 5 and a leaf of 2, the data value is 52. Therefore, the most repeated temperature in Philadelphia over the last 14 days is 52 degrees Fahrenheit. How many days recorded a temperature greater than 30 degrees but less than 40 degrees? A number greater than 30 but less than 40 must be in the 30s. Therefore, it must have a stem of 3. Looking at the table shown, there are no digits in the leaf column for a stem of 3. In other words, no recorded temperatures were in the 30s. Therefore, no days recorded a temperature greater than 30 degrees but less than 40 degrees. Great job! There are lots of benefits to displaying quantitative data with a stem and leaf plot. Unlike frequency tables and histograms, which also display quantitative data, stem and leaf plots give more information by providing the specific values in the dataset. Additionally, they're easy to read and understand. Just by glancing at a stem and leaf plot, you can determine if there are any strong outliers in the dataset. In the last stem and leaf plot, 29 degrees was a clear outlier because there were no other temperatures close to that data value. Stem and leaf plots are also helpful because they show the shape of the data distribution. Similar to bar graphs, stem and leaf plots make it easy to see the symmetry, peaks, and uniformity of a dataset. Instead of using bars, stem and leaf plots use actual numbers to illustrate the data distribution. Let's look at a new stem and leaf plot showing the height of students measured in centimeters. Notice that the stems all have 2 digits. This indicates that all data values are 3-digit numbers. Let's use the stem and leaf plot to answer a few questions together. Is this dataset symmetrical? Explain. Symmetry describes the shape of a dataset. If the numbers are dispersed evenly, then the dataset is said to be symmetrical. This particular dataset is asymmetrical because most of its data values are in the 150s, 160s, 170s, and 180s. This dataset is described as skewing to the right. Are there any outliers in this dataset? An outlier is a number that is an abnormal distance from other numbers in the dataset. Since there are no data points close to 200, we can classify this number as an outlier. How many students are taller than 180 centimeters? To answer this question, we need to count how many numbers have a stem of 18, 19, or 20. Since there are 9 leaves shown for the stem of 18, 9 students are 180-something centimeters tall. 181, 181, 183, 183, 184, 185, 186, 187, and 189. Since there are no leaves shown for a stem of 19, there are no students with this height recorded. There's 1 leaf shown for a stem of 20, so the height of this student is 200 centimeters. Adding these together, 10 students are taller than 180 centimeters. I have one more stem and leaf plot for you to analyze on your own. This one's a little more challenging, but I know you can do it. The average man jogs at a speed of 8.3 miles per hour. The following data set lists the average jogging speeds of all members of a men's track team. 8.5, 8.5, 8.9, 8.8, 8.7, 9.1, 9.3, 9.7, 7.6, 7.8, 8.2, 10.1, 10.1, and 10.2. Answer the following questions about the dataset using the stem and leaf plot shown. Notice the key at the bottom explaining how to interpret the stem and leaf plot using decimals in the tenths place. Is this dataset symmetrical? Explain. How many members of the track team run faster than 8.3 miles per hour? What are the maximum and minimum average jogging speeds on the track team? Pause the video and analyze the stem and leaf plot and see if you can answer these questions yourself. When you're ready, resume the video and we'll go over the answers together. Now that you've tried these problems, let's go over them together. Is this dataset symmetrical? Explain. No, the dataset is slightly asymmetrical, skewing right. Based on the number of leaves given for each stem, there are more data points with low values, 7 to 8 seconds, than high values, 9 to 10 seconds. How many members of the track team run faster than 8.3 miles per hour? To answer this question, we need to examine data values with a stem of 8, 9, or 10. For the data values with a stem of 8, count the leaves greater than 3 for jogging speeds greater than 8.3. 5 numbers are greater than 8.3. 8.5, 8.5, 8.7, 8.8, and 8.9. 3 numbers have a stem of 9, 9.1, 9.3, and 9.7. 3 numbers have a stem of 10, 10.1, 10.1, and 10.2. Adding these together, 11 members of the track team run faster than 8.3 miles per hour. What are the maximum and minimum average jogging speeds on the track team? The maximum average jogging speed is the fastest speed recorded, which is 10.2 miles per hour. The minimum average jogging speed is the slowest speed recorded, which is 7.6 miles per hour. Great job! I hope this video about stem and leaf plots was helpful. Thanks for watching and happy studying.